Let's solve the initial value problem y double prime plus 4y prime minus 5y equals t times e to the power t with initial conditions y at 0 equals 0 and y prime at 0 equals 0. So we start by taking the uh, Laplace transform on both sides. By linearity, we start with the Laplace transform of y double prime. So we have the Laplace transform of y double prime, and then plus 4 times the Laplace transform of y prime, and then minus 5 times the Laplace transform of y, and we use the notation capital Y of s for that. And then on the right-hand side, we get the Laplace transform of t times e to the power t. So now we use the properties for the Laplace transform for the second derivative. And so the first part becomes s squared times y of s minus s times y of 0, and then minus y prime of 0. And then plus 4 times the Laplace transform of y prime, which is s times y of s minus y at 0, and then minus 5y of s. And on the right-hand side, we get the Laplace transform of t times e to the power t. We have to look that up in a table. Look at the table t to the power n times e to the power at, and you'll see that this Laplace transform is 1 factorial over s minus 1 to the power 1 plus 1. This is n plus 1, where n is the power of t. Okay, now let's simplify that a bit. Let's take a look at our initial conditions. Y at 0 equals 1. So we get a 1 here, and then y prime at 0 equals 0. So this is 0, and we have 1 here. So now let's combine everything with ys. So what we get is s squared, and then plus 4s plus 4s, and then minus 5 times y of s. And then we have minus 1s from here. So we have minus 1s. And then 0, and then plus 4 times negative 1. So these two come from the initial conditions. And then on the right hand side, we can simplify that a little bit. 1 factorial is just 1, and then over s minus 1 squared. Okay, we're going to bring this to the other side, and we're going to leave this on the left-hand side. So we have s squared plus 4s minus 5 times y of s, and then that is equal to 1 over s minus 1 squared plus s plus 4. And then we're going to combine this into one fraction, make a common denominator. And that will then become 1 plus s plus 4 times s minus 1 squared over s minus 1 squared. And so it follows from that we can solve for y of s, and that is equal to 1 plus s plus 4 times s minus 1 squared, all over s minus 1 squared, and then divided by, so in the numerator we get that we multiply this by s squared plus 4s minus 5. And in order to do the partial fraction decomposition, we have to note that this can be factored as s minus 1 times s plus 5. And so we actually get s minus 1 cubed. So in order to figure out what y of s is, we have to do the partial fraction decomposition of this expression. And I will leave the details to you, but we have 1 plus s plus 4 times s minus 1 squared over s minus 1 cubed times s plus 5. It will be broken down as follows. It's going to be a over s minus 1 plus, since this has multiplicity 3, we're going to have all the powers up to 3 show up in the partial fraction decomposition. So then we have B and then C here. And then we also have S plus 5 show up as a decomposed fraction. So plus D. And I will not do all the work here in this video. That is something that we've done in the previous version, previous section. So I'll just give you the outcome here. So if you solve this for A, B, and C, and D for smart choices of S, you get the values A equals 181 over 216. You get B equals negative 1 over 36. And then we get C equals 1 over 6. And then D equals 35 over 216. So when you break that down, you get that. And then finally, we have to find y t is the inverse Laplace of y of s. And so we take the inverse Laplace of this form, which is our y of s. And so we see for the first one is of the form 1 over s minus a. And so that's e to the power a. And the first part is just e to the power t with that coefficient a in front, 181 over 216. And then plus b times 1 over s minus 1 squared. That then gives us, well, not plus, gives us minus 1 over 36 times t e to the power t. And then we have plus 1/6 times, and then the inverse Laplace of 1 over s minus 1 cubed is actually 1/2 t squared e to the power t. And so this would combine to 1 over 12. And then our last part is plus 35 over 216 times e to the power negative 5t. And that is our final solution to this differential equation, to this initial value problem.